learned about the C programming. C programming is a powerful general purpose programming language. It can be used to develop software like operating systems, databases, compilers, and kernels, so on. In the C programming, we first learned about data types. There are so many data types in the C programming, like int, character, float, double, short int, unsigned int, long int, unsigned long int, unsigned long int, signed character, unsigned character, long double, etc. Mm. And next we learned about the conditional constructs and operators. The conditional constructs are used to organize basic condition loops or nested conditional constructs in an if then else if type of logical sequence to create complex expressions for evaluation. There are five types of conditional statements are there in the C programming. They are if else, nested if else, if ladder, switch statements, operators. Operators are divided into some groups. They are arithmetic operators, assignment operators, comparison operators, logical operators, bitwise operators. Arithmetic operators do the arithmetic operation, and assignment operators we will use to assign some values to the some variable. Comparison operators are used to compare the values. Logical and bitwise operators are some logical and bitwise operations. Arrays. Arrays are used to store multiple values in a single variable instead of declaring separate variables for each value. Syntax is data. First we have to define data type, and then we have to name some variable and in the square columns we have to declare the size of the letter. Pointers. A pointer is a variable that stores the memory address of another variable as its value. A pointer variable points to a data type of the same type and is created with the star operator. Functions. A function is a block of code which only runs when it is called. Recursion. Recursion is a technique of making function call itself. The technique provides a way to break complicated problems down into simple problems which are easier to solve. And we learned data preprocessing, storage classes, and unit structure. And now we briefly studied about the C++ programming. C++ programming is a powerful general purpose programming language. It can be used to develop operating systems, browsers, games, and so on. C++ supports different ways of programming like procedural, object-oriented, functional, and so on. This makes C++ powerful as well as flexible. It is, as earlier mentioned, it is object-oriented programming language. What is object? Object, any entity that has state and behavior is known as an object. For example, a chair, pen, table, keyboard, bike, etc. It can be physical or logical. An object can be defined as an instance of a class. So what is class? Uh, class is a collection of objects. It is a logical entity. A class can be also defined as a blueprint from which you can create an individual object. Class doesn't consume any space. And we next learned about constructor and destructor in the C++. Constructor in C++ is a special method that is invoked automatically at the time of object creation. It is used to initialize the data members of new objects generally. The constructor in C++ has the same name as the class or structure. Constructor is invoked at the time of object creation. It constructs the values that is provides data for the object, which is why it is known as constructors. Destructors. A destructor is also a special member function as a constructor. Destructor destroys the class object created by the constructor. Destructor has the same name as their class name preceded by the tilde symbol. It is not possible to define more than one destructor. The destructor is only one way to destroy the object created by the constructor. Hence, destructor cannot be overloaded. Destructor neither requires any argument nor returns any value. It is automatically called when the object goes out of scope. Destructor releases memory space occupied by the objects created by constructor. In the destructor, objects are destroyed in the reverse of the object location. And we briefly learned about the embedded C, what is embedded C, and what are the data types operators. We will see in the we learned in the um, embedded C. Next, we learned about the Internet of Things. And the definition of the Internet of Things is the network of physical objects that contains embedded technology to communicate and interact with their internal states or the external environment. There are 13.8 billion IoT devices in the world today, outnumbering the global population almost by twice. And the IoT technology leading in the industries are utilities, insurance companies, agricultural industry, factories, automobile industry, transport industries. Some consumers using Internet of Things. The end-to-end flow is given here is as in the figure. General technical requirements for IoT devices. It requires many devices and it required in large scale and it required vague security requirements, wage requirements, and it requires much volume of data uh, and it should be end-to-end integration devices. The challenges in IoT devices addressing is the biggest challenge in the IoT devices. Scale and scale because it requires many devices, connectivity, data volume, and so because it requires so many volume of data, device size it should be minimum or maximum. And next we learned about the embedded system. Embedded system is any combination of hardware and software which is intended to do a specific task can be called as an embedded system. For example, cameras, routers, computers, mobile phones, etc. Types of embedded system: standalone embedded system, real-time embedded system, network embedded system, mobile embedded systems, hybrid embedded system. Standalone embedded system acts as slave. It follows blindly. It takes a decision on its own or it's self-driven. And real-time embedded system, which completes the task within the deadline. For example, airbag systems, etc. And mobile embedded systems are it can be movable or able to portable. For example, smartwatch. Hybrid embedded system are it is combination of two or more embedded systems like standalone and real time or the standalone network or mobile, etc. And we next learned about the Arduino Uno. Arduino Uno is an open source microcontroller board based on the microchip 8 328P microcontroller and developed by Arduino.cc and initially released in 2010. The board has 14 digital I/O pins or input output pins, and in that six capable of pulse width modulation output and six input output pins, and is programmable with the Arduino IDE integrated development environment via Type B USB cable. It does not inbuilt with the Wi-Fi or Ethernet. Mm. And next comes to come to the our IoT internship project. It is nothing but IoT based home automation solution. In this project, the requirements are LED temperature system or ADC, LDR sensors, serial tank for communication, serial communication, Ethernet shield to communicate the Arduino with the serial tank or Blink mobile application, and Blink IoT app. And we use the software Pixim Lab Arduino IDE. We use Pixim Lab because we are not using the hardware. Instead of hardware, we are using the Arduino as a software in the software. It's LED. LED. Simplest device used to most on embedded applications as feedback. It LED works like just like a diode, and it is the advantages of the LEDs are is low energy consumption devices, and it lasts longer life. It's smaller in size and faster switching make it usable in wide application field like home lighting, remote control and surveillances, displays, and many more fields. This is the LED that is looking in the lab software. CLCD displays. These displays are most commonly used in display ASCII to display ASCII characters. Some customization is simple is as possible. There are three types of CLCD displays are in there. 16 into 1 CLCD, 16 into 2 CLCD, 16 into 4 CLCD. 16 into 1 means 16 columns and 1 row, and here 16 columns and 2 rows, 16 columns and 4 rows CLCDs. Next we use the temperature system. A temperature sensor is an electronic device that measures the temperature of the environment and converts the input data into electronic data to record, monitor, or signal temperature changes. Some of the temperature sensors are LM35, DHT11, LDR sensors, etc. LDR sensor. An LDR sensor is a component that has a resistance that changes with the light intensity that falls upon it. This allows them to be used in light sensing circuit. Light dependent resistors, LDRs or photoresistor are often used in circuits where it is necessary to detect the presence or the level of light. These are used in some street lights and many more applications. And the serial remote tank. The serial remote tank is a tank simulator controlled by serial protocol. The tank has several sensors and actuators that can be read and controlled using the communication protocol. The parameters of the serial communication port must be 19,208 M1 Blink. That is nothing but Blink IoT application. Blink is a full suite of software required to prototype, deploy, and remotely manage connected electronic devices at any scale, from personal IoT projects to millions of commercial connected products. With the Blink, anyone can connect their hardware to the cloud and build an no-code iOS or Android or web applications to analyze the real-time and historical data coming from devices, control them remotely from anywhere in the world, receive important notification, and much more. In this project, the requirements are uh, garden light control, temperature control system, water tank inlet and outlet, valve control. Now we will these are the screenshot of the project. Now we will see the simulation, and I dumped the code into the Arduino Uno board. Uh, the system looks like this. I will show the Blink application. First we will control the we will control the heater system. The heater is on and the cooler is on and heater is off. And the cooler temperature is 27.37 degree. Uh, mm, I will on the heater on cooler off. It is increasing the temperature. It is when it reaches 35 degree, it automatically turning off and decreasing the temperature. And the inlet, the serial tank, in the inlet valve is on. When it reaches 3000 ml, automatically off, and I will on the outlet valve. When water level is less than 2000, the outlet valve will be closed. This is the Ethernet shield, and this is LDR sensor, and this heater system, and this is LED, and this is